All right, so we're going to talk about the graphs of tangent and cotangent. One thing I just want to remind you, maybe you remember this term, asymptote. This is a line that a graph approaches, but it generally does not cross. I say generally because not in this math class, but in other math classes, sometimes you can actually cross it. It's kind of rare. So asymptotes, as it's related to today's lesson, we're going to see them kind of like cutting up. This actually is like a sketch of the tangent function, so we'll see these asymptotes kind of like this, kind of cutting up the tangent function. And so we'll be talking all about like how to graph these in this video. So first, let's just establish what tangent looks like. So I have just a base number of x points to use here. So let's just go ahead and do this. And so I'll make some space so we can do some calculations. Okay, so let's start with tangent of negative pi over 2. So just as a reminder, so if you wanted to calculate that, you would just find sine and cosine. And, you know, if you were really unsure of these things, you could always refer to the good old unit circle. Now, this unit circle has all the positive radian values, but if I just go the reverse direction, if I go this reverse direction, this becomes negative pi over 2. And so then these values here, these are really what I need. So remember, sine corresponds with the y value, x corresponds with the cosine value. So this would be 1 over 0. That's what this would come out to. So that's kind of the work that's involved when you're calculating these things. And of course, if I have 1 over 0, then I just get something that's undefined. So we will interpret this in a moment. We're just kind of going through and gathering some data right now. Okay, so let's keep going. So how about tangent of negative pi over 4? So moving on to the next entry. Okay, so again, if I wanted to use the unit circle to do this, so normally pi over 4 is this way, so if I wanted to go to negative pi over 4, I would go to right here, so this right here would be negative pi over 4, and here's the information that I need to, really plug all of this in, my bad. Okay, so, all right, so I plug that in, I get really negative square root of 2 over 2 over square root of 2 over 2. So this just equals negative 1, and so there you go. So we can just continue with this. So now what about tangent of 0? So that's going to be sine of 0 over cosine of 0. Hopefully we know those values by now, so that's 0 over 1, so that entry will just equal 0. And then for pi over 4, so we get square root of 2 over 2 for both coordinates, and so this just ultimately will equal 1, so that's the value of that. And then if I go back to pi over 2, that's going to be undefined. And then also, I just threw in a random point in here, 3 pi over 2, because this is also going to be undefined, so I just wanted to kind of make a point with this. Okay, so first thing I want to point out, notice I go negative 1, 0, 1. This should feel very familiar to like the sine and cosine graphs when we were working with that. But now I have these like undefined pockets here. So that's one thing to notice. And this actually is a period right here. So notice here's the block, and then from here on we restart the block. So you can see how it's periodic. We'll talk about that more a little bit later on. Okay, so I've got everything filled in. So let's go ahead and start interpreting this. Everywhere where your graph is undefined, these are asymptotes. Asymptotes are super important with tangent and cotangent to help you graph. You really want to notice the pattern with these. Okay, so now what I want to do is I want to just mark my axes so I can graph this. So I've marked it accordingly. So we're going to go pi over 2, pi, 3 pi over 2, etc. Okay, so whenever you graph tangent or cotangent, what you're always going to do is you're first going to start by marking your asymptotes. And I made 3 asymptotes here just to help you trust the pattern. So you'll notice that these asymptotes, so here's an asymptote, here's an asymptote, there's definitely a pattern to them, right? It's like you go through, this would be 0 and then to pi over 2. So this is a length of pi. And then I go another length of pi, I have another asymptote. So if I wanted to reverse, if I went this way, I would have one more asymptote over this way. So there's this pattern to them that you can trust. So that's kind of the point I'm trying to make here. Okay, so now you can see I've marked the 3 other points that we found, negative 1, 0, and 1. And I'll just show you now. So if I connect them, it's a little hard to make it look quite right, but this is kind of the first part of tangent. It's got this wavy shape. Let me just show you this on, let's look at Desmos real quick. Okay, so I just plugged tangent into desmos.com just so you could see it. So you can see, like, if you zoom out a little bit, you've got this like kind of wavy-ish shape, and then if I zoom in, you can see it a little bit more. I'm pretty zoomed in for what I've drawn. I don't have the axes quite right to make it look quite so wavy, but I just wanted to make sure you knew that this is really what the graph of tangents should look like. Should have this kind of wavy shape to it. So no doubt my wavy shape totally sucks. I'm not gonna lie, like for this video, I think I've tried to draw this like 10 times. I don't know what is wrong with my hand today, but it's just not coming out wavy, so I wanted to make sure you saw that, okay? All right, so we've like established the first block here, and so just like with sine and cosine, like now that you kind of see the pattern with the points, so I can continue this pattern, so having this, you know, first dot, second dot, third dot, so first dot, second dot. So I can just kind of, you know, with the points, I can kind of continue the pattern to create the graph. And some of those look a little more wavy. You know what, I did my best. Okay, so that's the graph of tangent, so just remember that. Now let's talk about the graph of cotangent, and again, I've just chosen a couple of good points to work with here. Now we already know to expect the asymptotes in this case. Let's go ahead and just blow out the detail here. So the thing just to remember with cotangent, it's cosine over sine. I'm not going to show you the unit circle this time. I'm just going to omit that and hope that you kind of remember some of the values at this point. So cotangent of 0, so of course I'll take cosine of 0 over sine of 0. I get 1 over 0, so this is going to be undefined. Then I can move on to cotangent of pi over 4, so that's the next entry. So cosine of pi over 4 and sine of pi over 4, this is actually just going to come out to square root of 2 over itself, so that will equal 1. Then I have cotangent of pi over 2, so moving down the table, so plugging these parts in, I will get 0 over 1, so that just is going to come out to 0. And then 3 pi over 4, so this will give me square root of 2 over negative square root of 2 over 2, so this will ultimately simplify to negative 1. And then finally, going back to cotangent of pi, so once again, I will be left with cotangent of pi. This will come out to 1 over 0 again, so this will be undefined, so just pointing that out. So I've got, that's undefined, and then once again, the period starts over again, so we repeat the pattern. So once again, we do have that period again, so same idea as tangent. And I can take these points now, and so I know a few things at this point. I know that these are going to be asymptotes, so I want to keep those in mind. I want to graph those first. So I'll go ahead and I'll set up my axes once again. And once again, I'm going to mark my asymptotes. So I started here at 0 and pi, and then I just continued the pattern. And so that's what I would recommend that you do too. Like once you get that pattern, go ahead and just kind of set it up for yourself. Okay, and then next I'm going to go ahead and I'm going to graph these points or plot these points. So I've got this point, and this point that I've gone ahead and plotted, and then still the same kind of wavy shape. Again, mine looks kind of crappy, so let's look at Desmos. So here's Desmos, so I just went ahead and plotted out cotangent. So again, you can see that wavy shape kind of going in the opposite direction. And again, if I just zoom in, same kind of ideas here, that wavy shape. Mine just totally failed to look like that, but I tried. Okay, I really did try. So anyhow, so now that I have this all set up, we can go ahead and we can extend the points, right? We can continue the pattern, and so then we get that same graph or something similar to what we just saw in Desmos. So it kind of worked the same. So we've already talked about this, but both graphs do have a period. For either graph, so it could be of the form a tangent bx or a cotangent bx, we describe the period as pi over b. So this is a little different from sine and cosine, but pi over b would be the period. And we'll use it in a very similar way, so I'll show you how to do that as we move through the video. Now, the general period for just tangent of x and cotangent of x, since they have a 1 attached to them, the period for both of those would just be pi. And you can see that, right? So one, we kind of talked about that. So if I go from here to here, so the entire length of this interval is pi, and you can see that, right? So if I go from pi over 2 to pi over 3, this is a length of pi, and then you have the, so this is one period, and then the period repeats itself in the next pi interval, okay? So we can see how these are periodic in their own way. Same thing for tangent. So this goes from 0 to pi. You can see that it's got that pi period width again. Now, as far as where the graphs are continuous, so I did just want to mention this. So if I want to be lazy, I can say they're everywhere. They're continuous everywhere except at the asymptotes. If I want to be a little more specific, which I probably should, the graphs are not continuous really when you have the asymptotes. So in this case, for tangent, they would not be continuous at any value of x equal to 2n plus 1 times pi over 2. So what does this mean? I've talked about this in other videos. This is how we format an odd number. So anytime you have an odd integer times pi over 2, you will have that asymptote. So that's where they're not continuous. And then for cotangent, anytime x equals some version of n times pi, so 1 pi, 2 pi, 3 pi, 4 pi, whatever, then cotangent will not be continuous. So let's talk about the domain then. So since we know where these graphs are not continuous, that also helps us to define the domain. So domain looks almost the same as where I'm describing they're not continuous. The way that we read this is the set of x such that x is not equal to the odd numbers times pi over 2 where n is an integer. So this is just how we format that. And then for cotangent looks very similar. This is a set of x such that x is not equal to n pi where n is an integer. So almost the same as what we were talking about with continuity. And then the range for each function is just negative infinity to infinity. So there's no limit on the range for these functions. Okay, so let's talk about x-intercepts for these functions. So for tangent, the x-intercepts will have this form n times pi, and cotangent will have x-intercepts of the form 2n plus 1 times pi over 2. So let me just show you what that means. Let me just go back to the graphs real quick. Okay, so for tangent, so look at where these graphs are intersecting the x-axis. Negative pi, pi, 2 pi, that's what we mean. And then for cotangent, so just look at where the x-intercepts are. Negative pi over 2, 3 pi over 2. So that's what they're trying to get at when we write out our x-intercepts like so. So as far as symmetry goes, I do want to say that both tangent and cotangent are odd functions. Just want to mention that. And then for amplitude, there's no amplitude for either of these because these graphs, so look at them. Neither one, they don't have a minimum or a maximum point. That's the thing you need with amplitude, so they don't have amplitude. So there is none. Okay, so one of the keys for graphing these is going to be finding two asymptotes. And there's a very easy way that you can find the two asymptotes. So for tangent, if you have an equation of this form, a times tangent of bx, you will solve bx equals negative pi over 2 and bx equals pi over 2. And if you have cotangent of this form, then you'll solve these equations, bx equals 0 and bx equals pi. So these actually make sense if you think about them in the terms of the graph. So the way that I think about them, and I'll repeat this as we go along here, but negative pi over 2 and pi over 2, those are like your standard intercepts. So if you make any change to x, you can still set them equal to those like first two intercepts that we found. And then you can kind of make a modification by setting up those equations. And then notice for cotangent, so 0 and pi, that's where the two asymptotes are. So again, like I think this will make a little more sense as we're going through it, but I did want to point out like there is a connection to the graph when we're solving those. So this is super key, and I'm going to show you how to use this now because we're going to jump into graphing a couple of other graphs. So working with period and tangent. So we're going to start with tangent of 2x. So the first thing that you're going to want to do with this is first you want to figure out what's the period. The period is pi divided by 2. So remember, it's pi over b. In this case, I have 2 sitting in the b position, so pi over 2 is going to be my b. Okay, so that's one thing you want to do. The other thing that you want to do is you want to find the asymptotes. Now, that's where this information comes back into play, okay? bx equals negative pi over 2 and bx equals pi over 2. These are the two equations that I want to use, but I have to modify them now for what I've got here, so I've got to put 2 in that b position. So set them up like this. If I go through and I solve for them, bada bing, bada boom, I get x equals pi over 4 and x equals negative pi over 4. If you didn't follow the math on that, I have to obviously divide both by 2, and pi over 2 divided by 2 comes out to pi over 2 times 1/2, so just showing you what my math was here. Okay, so very important when you get to this, look at your two values, and the lower value is where you want to start your table. So this is negative, This is the lower of the two values. This is where I want my table to start. And then, just as a check for ourselves, this will be the end of our period. So if we do things right, this should naturally end up being the end. So we'll see if that works. So the lower valued -pi/4, that's where we start. Now we take our period and we divide it into two parts, similar to how we did that with cosine and sine. So if I take pi/2 and divide that by 4, I will get pi/8. So these are the steps that I want to take after my initial point has been set. So we're going to take these steps. So we're going to take pi/8 steps. So if I start with -pi/4 and I add pi/8 to it, that will equal -pi/8. So that will be my next step. So now I need to add pi/8 to this. So if I add pi/8 to this, of course it's going to equal 0. That's an easy one. And then I think we can just continue this on. So working with our pi/8 steps, 0 plus pi/8 will be pi/8. If I add another pi/8 to that, that'll simplify to pi/4. If I add another pi/8 to that, that'll simplify to 3pi/8. So similar to like sine and cosine functions, the big hurdle you have to get over is figuring out what points you want to use in your table. And then once you figure out that, you can just calculate your y's and the rest of this kind of comes together. So let's go ahead and just go through calculating some of the y's here. So I can just plug these in. So tangent of 2 times -pi/4, so this is going to become tangent of -pi/2, that's undefined. Now remember, this was supposed to be an asymptote, so it's fine that it's undefined. That is what we were hoping for. Next, if I move on to -pi/8 and I plug that in, this is going to come out to tangent of -pi/4. You're going to start to notice a pattern with these as you graph these, and so this is going to come out to -1. Tangent of 0 is just going to be equal to 0, and then if I plug in tangent of pi/8, that's going to be 1. And then pi/4, once again, is going to be undefined. Now remember, pi/4, that's what we said that the end of the interval is supposed to be. That's what we just found when we were doing, remember this work? So this is supposed to be the end of our interval. So that's actually what has naturally emerged, and we have confirmed that it is an asymptote. So we can feel pretty confident about that work. So, and then we can see that the interval starts all over again. Okay, so we've got all of our points. Now we've got to graph them. We got to go through everything. So first I got to set up my axes. So this will be 1 and -1, and I'll go by pi/8. So I'll set up my axes like that. And the first thing you want to graph will be your asymptotes. And then after we get our asymptotes set, we can go ahead and plot our points. So I've got kind of those main points here. I'm just graphing the ones for this first period, just so I can kind of get through that. Connect those to make my wavy shape, and then if I wanted, I can continue on with a couple more points, so I can continue the pattern. Now, with the way that I've drawn these axes, I don't have room to show more asymptotes, so this graph's a little bit cut off, but I could kind of continue it out this way. And so, yeah, so that's it. So that's how we graph that. Okay, so let's do something a little harder now. So let's do -1/2 cotangent of 4x. Okay, so I'm going to challenge you to do this one on your own. Again, you will get more out of this if you are working on this on your own. So the first thing that I want you to do is I want you to determine the period of this. So maybe just pause here, write down what you think the period is, hit play when you're ready. So the period in this case is going to be pi/4. Okay, and then the next thing that you want to do is you want to determine the asymptotes. And I'll give you even a big hint here. So here's the form of your asymptotes. So here's the equations that you need to solve. Again, pause here and try this and then hit play when you're ready. So if I plug in the 4, so what I get is x will equal 0 and then x will equal pi/4. Now, from these, which one do we want to view as our start point and which one do we want to view as our end point for a period or for an interval? This is where we want to start, okay? And then just one other note, so this -1/2, so this is going to just flip what the normal graph of tangent would be, so just something that won't alarm us when that happens. Okay, so now what I want you to do is we've got that starting point. What I think you should do next is you know what the period is, so divide this into 4 parts and come up with the next steps in this table, and then hit play when you think you've got that. So like we said, the period is pi/4, so I need to divide that into 4 equal parts. So I take pi/4 divided by 4. I've been making too many videos today. And this becomes pi/16. So these are the steps that I need to take. So I start at 0. At least we're starting at 0, so I think the math's a little bit easier. So if I just add pi/16 to that, then I get pi/16. If I add pi/16 to this, I get 2 pi/16, which will simplify to pi/8. if I add this, again, this comes 3 pi over 16, and then 4 pi over 16, which will simplify to pi over 4, and then 5 pi over 16. So I've got everything that I need here. And so, okay, so now from here, you should know what to do. So you just need to start calculating your y's. So again, I would recommend that you pause the video here. I know this is a challenging part, but go ahead and pause the video here and try to finish this out and then hit play when you think you've got the whole thing. So I'm going to go ahead and I'm going to start doing some math here. I'm going to start calculating. So, okay, so I plug in 0 first, and I get that that's undefined, so that was what we wanted. That was an asymptote, so that's fine. If I plug in pi over 16, so if I plug it into this, what this will come out to is just be careful with your math. So 4 times pi over 16 is going to become pi over 4, and then negative 1/2 cotangent times pi over 4. Pi over 4 is going to equal cotangent of pi over 1 is equal to 1, but then when I multiply that by negative 1/2, this whole thing will equal negative 1/2. And then, so next we have negative 1/2 cotangent 4 times pi over 8, so that will simplify then to negative 1/2 cotangent pi over 2, so that's just going to equal 0 because cotangent of pi over 2 is 0. If I continue on with 3 pi over 16, so I've got my work here, so this will simplify to negative 1/2 cotangent 3 pi over 4, so that'll equal negative 1/2 times negative 1, so this ends up becoming a positive, which we would expect, right? We always have a negative and a positive when we're going through these. And then as I continue on, this will be undefined, and then the period starts again. Okay, so I've got all my points, so now I can go ahead and get to work. So first things first, I gotta label my graph, so I've adjusted my axes accordingly. And okay, so now I'm going in these pi over 16 intervals. So, you know, first I want to set up my asymptotes. So I know that I'm going to have an asymptote at 0 and at pi over 4. And then I can also set one over on the other side over here to continue that pattern. In this case, I have enough room on my graph to continue this pattern. Okay, so now I can go ahead and graph. I'll first graph these 3 main points. So I've got pi over 16, negative 1/2, and then this one, and then this one. So I've got the 3 points, and so then I can connect them to make, I don't know, that's probably like the closest I've gotten to making the shape look right. So I'm gonna pat myself on the back for that. And okay, so now we're there, and then we can continue the pattern. So I can put a couple more points down that follow the same pattern as the previous period, connect them, bada bing, bada boom, you got your graph. All right, so, whew, a lot of information. If you found this helpful, consider leaving a like on the video, leaving me a comment, sharing it with a friend, or subscribing to the channel. I super appreciate that. I like offering free math help to the masses, so whenever you do that, that really does me a solid. And otherwise, I will talk to you guys in the next video. Thanks for watching.